I know, sorry. Alright. One more thing I want to go. So you guys get the concept there. I want to make sure we understand this. When you have the parallel lines, it cuts the transversal into proportional parts. Okay, that's really important out of today's lesson. The next thing I want you to do is take a look at the notebook paper you guys are writing on. What do you notice about the blue lines? Two things. Parallel and they're equidistant. Same distance, right? Now take a look at the red line. What do you notice about the segment of the red line between each one of the blue lines? What do you notice? Not a bisector. But it cut, okay, the red line represents the transversal. But what do the blue lines do to that transversal? Cut into what type of parts? Equal parts. If your parallel lines are equally spaced, it cuts the transversal into equal parts. In fact, if you were to take a line and go straight diagonally across the page, that length of that transversal between each one of those blue lines will be the same every single time. So this leads us to the next big idea, that if the parallel lines are equally spaced, then it cuts the transversals into congruent parts. That's something I want you guys to write down. If the lines are equally spaced, it cuts the transversals into equal parts. So here we go, last two examples. First, what can you tell me about these two lines? Sebastian.
That x minus 3 is half of x plus 12.
Okay, how do you know it's half?
Because the base similar retard is always half of the base.
Okay. Not only that, but again, they are parallel, correct? All right. And what do you notice about what does that parallel line do to your transversals? Yeah, they're equidistant. So therefore, y plus 8 is equal to 2y minus 4, so that's one equation you'll need. And then the other, especially you just told me, that, now this is another way. You said that the midsegment is half the base. So maybe if I went from the base is what of the midsegment? 2 times of the midsegment. Yes. We're almost done here. Okay. Just got one more example to go. Alright, number 4.
Is that you right?
Solve for x and y. I figured you guys can do that. So this is in Algebra 1. You guys should be able to solve those. Alright, so on number 4, guys, we have the staircase. Some of you guys might have staircases where you have this situation. We've got the wall and you've got these little strips going up and down your wall. What I want you to notice here is we actually have 3 triangles here together. We have the big triangle. Then we have another triangle. Then we got that third triangle all the way down there at the bottom. What's
make it bigger?
Let's see. I might be able to zoom in just so you guys can get the image. Well, what do you guys notice about all three of those triangles? What's true about them? They're all similar. What does that tell you about the corresponding sides? They are proportional. Not only that, but also take a look at this from another perspective. What do you notice about the three strips? How are they related? Okay, well, okay, so that's the width between them, 12.5. Well, what's true about each one of those?
The sides are all parallel?
The parallel, very good. So our trim is parallel. And remember we just learned that if you have three or more parallel lines, then cut your two transversals into proportional parts. Do we agree? Okay, so what that gives us, again, this is kind of weird at first. That gives us x over 2.5 equal to y over 2, which is equal to z over 1.5. What's the problem?
X, Y, and 0.
Well, no, they're not equal to each other.
No, they're equal.
No, they're not equal to 8.
No, all.
Okay, so x plus y plus z equals 8. Okay, I'll go with you on that. Well, why can't I solve this in its current format? Yeah, you got three unknowns in a problem. You can't solve an equation when you have more than one unknown. This presents a problem. Remember, we said that there were three triangles there, correct? So this little portion right here, which is the slanted edge, if you want to think like that, over this flat edge, is going to be similar to the entire slant over the entire flat. So all three of those are then equal to 8 out of what? 6. Just solve from there. And I would solve each one of those individually. So 8 out of 6 reduces down to 4 over 3 is equal to x over 2.5. 4 over 3 is equal to y over 2. And 4 over 3 is equal to z over 1.5. And that will allow you to solve for x, y, and z. And really, if you've got x and y, you can figure out z as well. So you can necessarily do that by proportions. Okay, guys, do we have any questions on the two big ideas from today's lesson?
No.
Parallel lines are equally spaced. It cuts the transversal into equal parts. Otherwise, three more parallel lines, you get proportional parts on the transversals. Okay, your homework is on Math Excel, labeled, I think parallels and proportional parts might be parallels and similarity, but it's all there together. Okay, make sure you look at the title before you guys start doing the homework. So again, a lot of you guys are doing the wrong homeworks on the wrong dates. Okay, so please make sure you guys are looking at that. I do have the entire week's worth of homework posted. So if you guys get done, you want to start on tomorrow's homework, go for it. Okay? Yes? Well, I meant to tell you guys about that on Friday. We didn't get around to it, but I did have one posted for today's lesson. There is not a video for tomorrow. It's Pythagorean theorem. I figure you guys have had enough experience with that. You don't need the video for me to kind of give you a preview. We'll start videos for Wednesday's lesson, so you guys will have videos to watch tomorrow afternoon. Okay? But you don't have videos to watch tonight. Okay? So just Math Excel.